Hello everyone, welcome to this video. In this video, we are going to see about the Theano library which is used in machine learning, and this will be the part 1 and the part 2 will also be uploaded in our channel later. Okay, so let's get started. So first, what is Theano? Theano is an open source library where it is a compiler for mathematical expressions in Python. It knows how to take the structures and turn them into a very efficient code that uses NumPy, efficient native libraries like Blast and native code, which is used under C++ to run as fast as possible on CPUs or GPUs. It uses a host of clever code optimizations to squeeze as much as performance as possible in your hardware. So if you are into a nitty-gritty of mathematical optimizations in code, so check out this video for more interesting tips. Okay, so Theano is mainly used as the subdivision such as language compiler, and it is also used as a Python library. So we are going to see one by one. First, language. So Theano language, and these are the overview where we will be seeing about Theano language, operations which are done under this Theano language such as scalar, vector, matrix, tensor and sparse variable, and then we are going to see about linear algebra and the element wise nonlinearity and convolutional extensible. So there are these much what to say, like these much factors which are involving this Theano, but we are not going to see all of this. We are going to see about only this scalar and vector matrix, and in this part we are going to see about in this video. So first, using Theano we can do three different things. First, define an expression, compile an expression and execute an expression. Basically what is defining an expression is like we need to define a function or a expression into a function variable. After that we are compiling that, like we are using that function and then we are calling that function. So that is what like executing the expression means, like we are taking or we are running the expression to get the correct output. So these are the, like what are the max variable or the max operations which can be done using Theano. First one is scalar, second one is vector, third one is matrix, fourth one is tensor, fifth one is reduction, and sixth one will be the DIMSHUFFLE. DIMSHUFFLE is nothing but it is a dimensionality shuffling. Now first one will be the scalar math. So what is a scalar math represents? So generally scalar will be represented by uh, a dot product, and a star, like it will be represented by a star. So if we need to use this piano library, we are going to import it from, and like we are getting the tensor. So after importing the tensor as t, we are using it to scale it. So x is equal to t dot scalar and y is equal to t dot scalar. Like this is generally the type of operation like what we are going to do, either scalar or vector. So and then we are giving the expression like the z is equal to x plus y and w is equal to z star y. So now the first function should, like we should be squaring, we should find the square root of the w, and we need to find the expression of this a. So that, from where do we using this expression and this square root function? So that is from this t. So this t means this tensor will be available only under this Theano library. After that we can be easily calculating what and what, like the expression log and the square root, everything. So like this will be an example for scalar math. And next we have this vector math. So what kind of operations do we have in vector math? Let me see. So first we are importing the tensor and we are initializing it to a vector operation, so x and y. After that this will be a scalar math applied element wise, and if we come to vector, like it will be of dot product, so t dot x comma y, and if you want to broadcast this, like it will add both the variables with respect to a dot operator. And now we are going to see about this matrix math. What is matrix math will be of, we have a separate rows and column where the rows and columns will be stored from this matrix. So first we are initializing the x variable and the y variable to a matrix kind of operation, and then we are assigning the output or some another variable to a vector kind of operation, and then we are multiplying it both. So if we want to multiplying it both, like we need to do of dot of some two kind of variables, and we need to store it in as a vector variable. So these are the kind of matrix or some collaborated or some interrelated combinations where we have of matrix and matrix and matrix to vector, which is nothing but we can do an operation by both of the variables or being in matrix kind of operation, or like if one argument is in matrix and another argument is in of vector product, so we have no problem, like we can do all kind of operations. After that we have tensors. So generally tensors will be of an three-dimensional array where we have x, y and z axis. So this code is a little bit tough, so where this tensor will be first given to a tensor type, and we have false false false, and then we may do this okay. Generally the scalar, vector, matrix and tensor, all of them will be having the same kind of operations where first we need to assign the tensor, or like we need to import it and we need to assign it to a variable. After that we can use it for a dot matrix or either scalar or matrix, or whatever it is. Okay, so dimensionality defined by the length of broadcastable argument, which means x, y, and z. So these are the three axes, and we can add or we can multiply or whatever we can do. Duplicate tensors also broadcastable axes to make size match. Now reduction. Okay, reduction is nothing but you can see we can have a matrix. So from the matrix we are going to extract a few rows and column means, so that is called as reduction. How can we do it in tensors? So let me see. So tensor 3 is equal to a tensor type of variable is been assigned, and then we are assigning the tensor 3 to an variable x. So like I am summing up those matrix and I am adding it to the marginal, like I'm extracting the axis from 0 to 2 and I'm storing it in a margin of, yeah, margin. Okay, after that, even if you want, like I can assign like some of the access to some of the variable, and by calling those variable I can access those. So this is what generally reduction means. Okay, at last will be the dimensionality shuffle. So this dimensionality shuffle is nothing but if you want to, like if you want to portray or some of them, like we can if you want to convert a 2 into 2 matrix into 2 into 1, or like 2 into 2 matrix to a single dimensional array, so that is what it does. So first of all we are calling the tensor and we are assigning to a variable, and then say for example the dimension will be of 2 comma 1, so we are assigning a t, and then we can able to change the dimension of the previous matrix from 2 comma 1 comma 0 to 0 comma 1. So it will be doing the matrix operation internally, and it will produce the result as 0 comma 1, so which means 0 rows and just one column. When we are also an additional point to add a large tensor, we may use a variable called x. So it is an undefined, right? So maybe you used dynamically. So whatever the value we have been chosen, so that will be reduced, and like the dimensionality will be shuffled among those. So that's all for today's video, guys. So we'll be meeting on part 2 of this piano library. Until then, thank you.